The question says that a uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80 microcoulomb per meter square. Find the charge on the sphere. And the second question is, what is the total electric flux leaving the surface of the sphere? So by definition of surface charge density, we know that surface charge density sigma is defined as total charge divided by surface area. Now using this expression, we can find out the value of total charge on the sphere, as Q would be equal to sigma times A. Now A for the sphere would be equal to 4 pi r square. So the value of charge on the sphere would be 1.44 microcoulomb, 1.448 microcoulomb. Now the second question was, what is the total electric flux leaving the surface of the sphere? Now we can assume a Gaussian surface around this sphere, and as per Gauss law, flux through the Gaussian surface would be equal to total charge enclosed by the Gaussian surface divided by epsilon naught. Now since this Gaussian surface would be enclosing this charge, this magnitude of charge Q, 1.448 microcoulomb, and we can use this expression now for finding the flux. So flux would be equal to 1.64 into 10 to the power 8 Newton meter square per coulomb. Here we see that while assuming Gaussian surface, we can assume Gaussian surface that covers this sphere of any radius. So just the sphere should be inside the Gaussian surface.